Hi. In this video I want to introduce you to wildcards and erasure. In generic code, the question mark is called a wildcard or also a wildcard type. It represents an unknown type. Wildcards can be used in variable declarations instead of type parameters. They can be upper bounded, unbounded, or lower bounded. Let's start by having a look at upper bounded wildcards. They are used to relax restrictions on a variable. Here I have my wildcard, the unknown type, that extends upper bound. Extends can apply to either classes or interfaces. The unknown type is either the upper bound itself or a subtype of the upper bound, a type that derives from upper bound. Let's look at an example. Here we have an unknown type that extends number. This unknown type could be number, it could be big integer, it could be uppercase float or uppercase long, etc. Any type that derives from number or number itself. Here we are talking about a class. Extends could also apply to an interface. I could say I have an unknown type that extends flyable. Now this unknown type could be flyable or a class that implements flyable or a class that derives from a class that implemented flyable. When do I specify an upper bounded wildcard? We specify upper bounded wildcards when we need certain methods that are declared in a given class or interface, when we need that specific functionality. The subclasses will inherit the methods, and thus the functionality will still be provided in the subclasses. Let's have a look at unbounded wildcards. They are used when the functionality can be provided by any class, even by class object. We could have, for example, a method called printList and says, give me a list of an unknown type. Here you can think of the wildcard as anything. All I need is a list. I will print it, whatever reference type this might be. Lower bounded wildcards are kind of a counterpart to the upper bounded wildcards. Here we have an unknown type, the keyword super, and the lower bound. The unknown type is either the lower bound itself or a superclass from the lower bound. When do we specify lower bounded wildcards? We do it when we need to add elements of a given type to a collection. The elements have an is-a relationship to the superclass, and because of that they can be added. Here is an example. I could have a method, it's called append. What I want to do is I want to append a number. And I can say, well, I can append a number in any list as long as it's either a list of numbers or a supertype. It could also be a list of objects. Not a problem because a number is an object. You can specify an upper bound or a lower bound, but you cannot specify both upper bound and lower bound for the same variable. Let's have a look at type erasure. Type erasure is the process of removing generic type information after the compiler had already checked for type correctness. Here I have a list of integer, and after the compiler checked for type correctness, the list of integer is converted to type list. The Java compiler applies type erasure like this. First, it replaces all type parameters in generic types with the bounds the upper or lower bound. If no bound was specified, it replaces the type with class object. It inserts casts to preserve type safety. And it generates bridge methods to preserve polymorphism in extended generic types. Here is an example. I have a class, it is called node. It's a generic class, a node of type T. This node represents the node of a singly linked list, so I have a data item of type T and also a reference to my next node. Here's a constructor. It has two parameters to initialize the data and the reference to the next node, and it has some other members that are not further specified. Notice all the type parameters T. That's how the code looks before erasure. At that point, the compiler does the type checking. After the type checking, the type parameters are removed. In our case, those type parameters were unbound, so there was no upper or lower bound specified. In that case, the type parameter is replaced with object. Once again, all my T's turn to object, 1, 2, 3. All my node of T turn to simple node. The type parameters after erasure are gone.